All right, are we ready to go? All right, I think it is officially 2:30, so welcome to the last time slot of the last day of Pass Summit 2024. Woo! Yeah, thanks y'all for hanging in there and for coming. I am so excited to talk to you today about performance tuning in production. We're going to talk about a lot of P's today. We're going to talk about plan forcing, plan guides, plan correction, lots and lots of things that we can do in production when things are going badly to put a little Band-Aid on things and make things go better. My name is Kendra Little. My pronouns are she, her, and I am a database reliability engineer at an awesome company called Dutchie. And at Dutchie, we really care about reliability and stability. And so I use the tools that we are talking about today an awful lot to ensure a consistent performant environment for our customers. Now I'm at level 200 today. We're gonna cover a lot of stuff fast. We're gonna get into some cool details on it, but we're gonna try to also make things really accessible to folks. So even if you're new to these tools, I hope that you find interesting things that you want to look into and learn more about. I've worked in a lot of different roles in SQL Server, but I was especially excited when I found out that I had the last session of the day at PASS on the last day. I've actually never had this time slot before. And when I realized what time slot I realized I had an example to cope. I had an opportunity to co-present with someone who I've wanted to co-present with for a really long time, because last session, last day, it is the people who want the content the most who are still here. The people who are the most dedicated. It's been days of talking, days of learning. You're overflowing with information. If, like me, you're an introvert, you can barely talk to anyone anymore. So I realized, okay, I can do my dream. I can co-present with my favorite presenter because it's just gonna be me on stage. And so I invited with me today my co-presenter for this session. Here we go. Woo! His name is Dave. Dave, are you excited to be here at PASS? Yeah, I'm real excited to be here. Dave is an expert in SQL Server. Dave helps me all the time. And in reality, I get all of my information from Dave about what I do at work. Don't tell anyone at home. Now, after I already committed to bringing Dave here, yeah, she brought me a ticket. I found out this session was being live streamed, so This is going to be one to remember. So here we go. Dave and I are here. And what we're going to talk about today, we're going to talk about why to performance tune in production, which may sound wild to a lot of people. We're going to talk about plan guides in SQL Server, query store plan forcing, automatic plan correction, note the scare quotes on that one, query store hence, parameter-sensitive plans optimization, and some lessons that I have learned along the way. So first up, why in the world would we performance tune in production? It sounds really irresponsible at first, right? Who tests in production? Well, lots of people need to test in production. If something's going wrong and performance is bad and your customer is being impacted, their web page can't load, they can't check a customer out at a register, or some other thing that impacts their experience, it is time consuming to change the code and republish the code and fix that all up. Your customer may be sitting there waiting a long time and they don't like it, right? They really don't like it. Also, it can be difficult to identify and verify even simple fixes if you don't have a representative data set to production. Many performance problems are specific to the data and the parameters that queries have been run with in production. And making sure you can reproduce the problem outside of production itself can take quite a long time and sometimes require restoring databases, which even in really fancy environments, it can take a long, long time. So Dave and I, we do performance tune in production. We are careful. We work on making sure that we work within the processes. We make sure that what we're doing in production is in accord with our change management processes and that those are suited so that we can do performance tuning in production to put Band-Aids on things. Now, I love creating indexes to help solve problems or changing indexes to help solve problems. But, well, Dave, can we always create indexes when we want to? No, we can't. Big, big problems. If you're in Standard Edition, you don't get any online index operations. But even in Enterprise Edition, there are times where it's tricky to create indexes because system load is too high and maybe your change management processes just don't accept that as a low enough risk option for live workdays. So we do tune in production. Here's one example of a query tuning problem that I found in production over the years many, many times. There's a query that runs a lot. It runs very, very frequently, and maybe it's been performing fine for a long time. But all of a sudden, something changes. Maybe we've just added a bunch of data. Maybe data has just grown over time. Maybe also we've done something like index tuning recently. Something happens to change the query plan for this. And now suddenly, our query plan has a much larger resource memory grant than it used to. Maybe our query is saying, every time I run, I need to reserve 2 gigs of memory. If we're running this on a bunch of different sessions, we can actually steal tons and tons of memory from the buffer pool, from the plan cache, and queries, more queries who also need query workspace memory grants to do things like sorts and hashes, they can get queued up and not be able to start. So in this situation, in the old days, we used plan guides. We hate plan guides, but it was all we had at the time. We didn't know better. We would use a plan guide to say, no, don't use that new query plan. Use this other query plan that has a lower memory grant on it. Nowadays, I'm more likely to maybe use a query store hint to put a hint on there that says the max query workspace memory you can use query is lower than what you're using now, and see if I can tame it down that way. Or perhaps I could force a query execution plan. This helps that query not have to ask for such a big memory grant. Other queries don't have to wait for memory grants. Everything gets smooth, and we have time to look at the query and say, do we need to rewrite the SQL? Do we need to create an index? What are the tuning things we can do so that we can follow up on it and not have to apply this hint to it long term? So these are the demos that we're going to be looking into today. We are first going to take a quick trip into plan guides. Although I don't love them anymore, I think they are interesting to look at from where we came. So we're coming up on almost 20 years we've had plan guides now. They were introduced in SQL Server 2005, and a plan freezing functionality was introduced in SQL Server 2008. You were just a baby then, Dave. Yeah, you were just very small. There is no IDE for this. You use T-SQL to create plan guides. You use T-SQL to try to figure out if your plan guide is being used. You use T-SQL to get rid of your plan guides. So there's nothing like Query Store, and it works in Enterprise Standard, and Web Edition apparently still exists. There are 3 types of plan guides. The 2 on the left, Object and SQL, I'm not going to talk too much about those because those have largely been replaced by Query Store plan forcing and Query Store hints. Technically, they do a little bit more than Query Store will let you do. So ye old plan guides will let you do things like add a table level hint, so you could force an index with a plan guide, and you can't do that with Query Store hints. But for the most part, I have found that I don't need to reach for those. I can always find some other way to do what I need to do. The template type of plan guide hasn't really been replaced, and I'm going to do a demo showing you what that is. It allows us to say, if we have a non-parameterized query, it's creating tons and tons of execution plans, we can use a template plan guide to make that act like it's a parameterized query. We can basically apply forced parameterization to a single query without applying it to the whole database. Because if I just have one or two queries that aren't parameterized, I don't want to change a database level setting. I would rather just solve that problem with those. So what we're going to do is we're going to take a query who this one query, because it isn't using parameters, it has all sorts of different execution plans, and we're going to create a plan guide for it that says, hey, just pretend that this thing is parameterized. Don't create all these execution plans for it. Just go ahead and make it work, SQL Server, because it can make it work. So here we go. You rest there, Dave. You're doing great. It's his first time presenting. He's kind of shy. All right. So we are using a stored procedure here, but just because we're using a stored procedure doesn't mean that we're using parameterized code. We've got a little block in here. We're running some dynamic SQL that is just, it's counting the rows. We're using the Stack Overflow 2013 database. And it's counting the rows where the ID is less than a given number, and we're passing in some parameters to run that in a loop. So we'll run it a bunch. So we're going to run this first 1,000 times, and then we're going to run it another 2 times after that for some larger numbers there. So none of those were particularly slow. We can look in sys.dmexec query stats and friends to see how many query plans were created for things where the text of them, there we go, I want my control button, where the text of them is like this query. So if we look here, how many query plans did we get and what do they look like? We have 1,002 query plans. Let's drag that up. And here's where you can see all those, literal values, right? Each one of these, they're not parameterized. We can see each of them has that specific ID in there. So they're each getting their own query execution plan. We can also look at something called the query plan hash to see how many of those execution plans are actually different, right? We have 1,002 of them sitting in our cache. How many distinct plans do we have? We have 2 distinct plans. When I ran it for that larger set of numbers and it had to count more posts, it did a different plan than when it was counting small posts, but they're mostly the same plan. Now, if I create a template plan guide to force parameterize this query, I'm basically telling it, act as if you were a stored procedure. So that means I'm just going to get one execution plan, and I'm going to get the plan for whoever I compile it for first. So to create this plan guide, I'm going to show you, let's turn on actual execution plans. I'm doing Control M, which highlights this little button here to include actual execution plans. And when I run our example query there, we can see that what this plan looks like, it shows this literal value there in it, right? So it says, okay, it's less than or equal to 1. We're going to change that. So to change that, we're going to grab the exact text for the query from sys.dmexec SQL text, and then we're going to paste the exact text for the query into this set of procedures. Now, this is one of the pains with plan guides, is I don't have like a handy identifier to do this. I have to give it the query text. So if it doesn't match, it's not going to work. And this is the biggest frustration that everyone always had with plan guides. Like, plan guides sound great, but you would always find yourself in the spot where you're saying, why aren't you using my plan guide? And it was almost always because of some sort of text mismatching. So to create this, we're using 2 specific built-in stored procedures, sys.getQueryTemplate and spCreatePlanGuide. The first one, we create some output parameters that we feed into the second one, and we create that. And now that we've created that plan guide, it's essentially adding this hint, option parameterization forced. So now if I look at our actual plan, I can see, yeah, this is different. Instead of saying ID less than literal value, it has turned that into a parameter. And I can run that now for a lot. I'm going to run my loops again of queries. And now if I look in query store for this query, I can see I have one query text here, and it has had one plan that has run 1,003 times. Now, like I said, there are differences. Like this can help you in a couple of different ways. All of those query plans do take up some space. You might have 30,000 query plans. I mean, sometimes, depending on how this is run, it can create a whole lot of them. And some of them might be faster and some of them might be slower, and it's just really hard to sort of tell how is it doing. So this gives us one thing to look at, but we do have to make sure that it's going to run well with the plan that is in cache. So for example, we might have a case where it runs first for that larger number. What this is going to do is put a plan in cache that has parallelism. It is going to use multiple cores for this query now. Since I cleared that out of my cache and then I started again and I ran it for a value that needed a parallel plan. So now if I run this 1,000 times, it is going to use more cores every single time. And I do need to turn off my execution plans when I run it in a loop so that I don't ask Management Studio to display 1,000 execution plans. Now, in this case, it's fast. It's still 2 seconds, but it is actually slower than it was. So there might be some cases where if you force parameterize something, it doesn't always perform better. So there is some work left to the user, but it's still a pretty handy thing to be able to do in some situations. Now, in the demo script, which I have uploaded today to the PASS site, there's more on plan guides that are in there. But we aren't going to spend too long on plan guides today, just because there's much cooler, more recent tools that cover the bases to this. I did find that plan guides were tricky to particularly use with CTEs. Now, Dave, do you like CTEs? No. Dave spends a lot of time with Eric Darling, so he doesn't like CTEs a lot. Eric will tell you that he doesn't love CTEs, but yeah, plan guides, they were great when we had them, but we have better stuff now. One of the things that is better now, and something that I rely on very frequently, is query plan forcing in Query Store. This was introduced in SQL Server 2016. So happy. This is not an Enterprise Edition only feature. This is available in all editions. And essentially what you can tell SQL Server is, please run that plan that way. Now, the query has to have run that way in the past. SQL Server has to have collected that execution plan for the query. And Query Store is a database level thing, right? So that specific database has to know about that specific query plan that you want to force, but you can tell it, hey, just do it that way. So one example of a problem that we have had, well, I've had it, I don't know how many times in my life, is a force parameterization problem, where sometimes when a query runs, if it runs for just a few rows, it runs and it uses a little nested loop that is great if it just needs to grab a couple few rows. But then, if it gets rerun and it tries to rerun that plan and it needs to get millions and millions of rows, doing that nested loop join operator can be really slow for millions of rows. Just over and over and over again, it has to follow that nested loop. And another join type would be more appropriate. So let's look at a demo. I didn't let you talk much there, Dave. I'm sorry. I know you like attention. But we're going to check out what this can look like in action. So Query Store plan forcing. Do I have any fans of Query Store plan forcing in the room? I know I have a few. Okay, a few other people have done this. I think it is an incredibly useful tool, and I am so glad that we have it. So we're making sure, essentially, the stuff at the top of the script makes sure I always have the same settings when I run this. And I'm creating one non-clustered index on the post table. The post table in Stack Overflow, it holds questions and answers in Stack Overflow. And so it has a lot of rows. Even back in 2013, it had a lot of rows. So we're creating an index on favorite count, and we're including the ID column. Our query that we're going to be looking at, it is looking for rows from posts It joins to post types to see, are you a question? Are you an answer? Are you something else? But we only want to see posts where the favorite count is greater than the favorite count that we pass in to the stored procedure. And we want to know what is the total score and the count of posts by type. So go ahead and create that proc. And I'll turn on my actual execution plans. Sometimes this runs first for a very high value, and there are no posts in this version of Stack Overflow that have more than 21,260 favorite counts. But what this does is it gets a plan into cache that has very tiny estimates on it. I think we're only going to get one row back. It looked at statistics and it said, no, nobody's that popular, right? So this is going to be this plan is suitable for very, very small amount of posts. And we can rerun this for, there's lots of posts that have more than 10 favorites on them, but it's still, this still reruns pretty well for this, right? Even though if we look at this estimate down here, we thought there was one row, there was actually 117,000 rows, but it only still took, 0.5 seconds. It's not too bad. It's not too bad. But what about one? There's way more posts who have one favorite on them. So this is taking 6 seconds there to do that. And when we look in the plan properties, we can see a bunch of that time was spent on the nested loop with the key lookup in it. We did have a spill over here on our sort that also slowed it down as well. But it can get even worse, because what if I want to know about posts who have 0 or more favorite counts? Well, this will complete, but it's going to take like 40 seconds. So I'm going to cancel it because I don't want you to have to wait 40 seconds. We might have a situation, though, where other counts run first. So I've run SP recompile against the stored procedure, which says, hey, the next time you run, generate a fresh execution plan. Now I'm going to run this for 50 favorite counts. So now I do get a better estimate. It knows, hey, it's pretty right on about that. There's going to be about 15,621 of those. Oh, that's pretty good. Well, that's nice and fast. So if that one happens to run first, oh, and notice also the plan. We got a parallel plan. We got a bigger size plan for this one. It said I'm going to use multiple cores for this one because it's enough rows to deserve that. So if I rerun this, even if I rerun it for a smaller amount, it's still going to reuse that parallel plan because it's in cache. And now if I run it for favorite count equals 0 with this parallel plan in cache, it's not so bad. It only took 4 seconds for the one that normally takes 45 seconds if I had let it run. What if, though, it runs first for favorite count equals 1? If it runs first for favorite count equals 1, I get a completely different and super fancy execution plan. This time, it did decide to do a clustered index scan of the posts table. So that's a thing. And then it's using an adaptive join to go into post types. Now, this really isn't, the adaptive join in this case really isn't that important because post types is tiny. Post types has like 5 rows in it. It just is like post type ID 1 is question, post type ID 2 is answer. So this join down here wasn't the problem. It basically got rid of a key lookup and was just like, forget it. You want so many rows back. It is such a high percentage of the post table. I'm not going to even use that non-clustered index you have on favorite count. I'm just going to scan the whole darn post table because most of the rows that I need are in there. And now if I have this one in cache, I'm gonna, there we go, yeah. I thought I was running a loop with plans on again. I am not, I'm just running it for a high favorite count. Now if I rerun this, even for that high favorite count where, this is pulling back no rows, we're doing that clustered index scan of the post table there. So we're doing a lot of I/O there, and it's not that much fun. So this plan is actually pretty fast, but it can introduce problems. It can take up large amounts of my data cache to be scanning that post table over and over again. And other tables may not have as much room in cache. I might start doing a lot of physical reads. And if I have slow storage, like if I'm using Azure SQL Managed Instance, then that could actually create performance problems for me. I want to keep as much data in cache as possible. I might also run into more locking and blocking problems if I am scanning a table. So that might, even though it's fast, that might not be my favorite thing to do. But I definitely don't like that little tiny query that really reuses badly. I want to make sure I don't get that. So we can find this query in Query Store in a variety of ways. We could look at our top queries, but if we have a really busy instance, it might not just be it might be a problem, but it might not be in like the top 10 of our queries, depending on how many other problems we have, right? We can query the Query Store dynamic management views and say, hey, in Query Store query, show me the query ID and info for this stored procedure. I can see that this is query ID 7. So I'm going to go ahead and open up the Query Store view I use the most often is called Tracked Queries. And I love this because I can just pop it open and I can just put a query ID into it. So personally, the way I use Query Store is I write a lot of queries against Query Store query and its related friends, and then I find the query ID I want, and then I use it in this view. I am going to change this to only look at, by default it looks at the last day. We're going to look at the last, let's just say 5 minutes so that they get spread out. So we can see here the square, this is the one I canceled. So if you see a square, it might be the client initiated the timeout basically on this, which is why I got the square. But we can see that plan that happened there for that query as well. We can click here and we can see the parallel query plan that we got that still does the index seek, but also does the key lookup. And here is the query that does the clustered index scan. Now, if I'm going to force a query for this, I might actually choose to force this one because I don't really want to force that one with the plan. So I can see over here, this is plan ID 8, right? So I could go and force that in T-SQL because I am query ID 7 with plan ID 8, or I can go ahead and click the force plan button there. When I click the force plan button, I get the little check mark here indicating that it is a force plan. And I'm actually going to switch this to go back for the last 15 minutes. Just there we go. I wanted just that whole view of all of the plans to show up in there. So now that I've forced that plan, which I could have done, like if you want to do this in code, it's very easy. You just pop the query ID into SP Query Store force plan, the query ID and the plan ID. And now that I've done that, the force plan is going to stick no matter how often I recompile this stored procedure. So because I'm telling it, even if you recompile, still use this plan. So even if I run this first for favorite count equals 1, this had compiled with the plan that scanned the clustered index. It's still using my query plan that I forced that has the parallelism with the key lookup. So even if I force it to recompile again and I run for the high query count, this is the one that had the tiny non-parallel query. I still get that query plan. And even if I run it for favorite count equals 10, that has happened. So I can refresh over here in Query Store, and now I can see, yep, my plan that I have forced is still running. And if I hover over this, I can see how many executions has it had, what is the average duration, etc. So this visual is super simple. It doesn't have commas. I like to say that we can't afford commas or localization in this view because we just haven't found the money for it yet at Microsoft. I don't know what the real reason is, but I know commas are not in every culture, but we do have localization. Anyway, but we can't afford the commas. They're too expensive. So someday, maybe, if we all chip into a GoFundMe, perhaps we can get commas. But yeah, I've forced my plan now in Query Store, and we are off to the races. And I still have my 3 plans, 2 of which are parallel, 1 of which aren't. I can see them both in those views in Query Store as well as in the GUI. So nice and pretty simple. What could be complicated about this? Oh, let's switch back this way. There we go. Let's switch back that. What could be complicated about that? So has anyone here ever heard of this very bizarre term, morally equivalent plan? All right, we have one person, two people who've heard of morally equivalent plans. This is not a real term, but I just didn't know what to call this, and the only references I could find to it were Erland Sommerskog heard from Connor Cunningham, who works at Microsoft, that maybe that's what this is called. When you force a plan, someone came up to me the other day, and Dave, you play the person who actually he asked someone else, but I butted in. So you play the poor person I butted on one. And what was his question? His question was, I forced my plan, but it's still using other plans. Why didn't it work? Why didn't it work? Right? He was much more sophisticated than that. But what he was seeing was he still has that check mark on his query plan. Like it worked when he didn't get an error when he forced it. He has the check mark. But now he's seeing other colored dots appear, even though it's still checked. So these are most likely, I haven't seen his queries, but most likely these are morally equivalent plans, because when you force a query plan, you're actually forcing the shape of the plan, the general nature of the plan, the essence of the plan, the form, I guess, the Platonic form of the plan. And if there are different row estimates that come up at times, it can create the same shape, but different plan. It has a different query plan ID, it has a different query plan hash, and in the properties of the plan, if you look at the properties of the plan, it will say use plan equals true. So it does look like your query store is haunted, yes? Great question. So the question is, the query plan that we have in Query Store, is it the estimated plan or the actual plan? It is an estimated plan that is updated with aggregate runtime stats. So really all we have in SQL Server are estimated plans. We have this term actual plan, but when the query optimizer thinks of a query plan, it always thinks of an estimated plan. It never comes up with an actual plan. When we ask for an actual plan in a tool like Management Studio, what we are getting back at the end is the estimated plan that has been updated with the number of logical reads it did, the amount of CPU it used. It's been updated with runtime stats for that query. Those runtime stats aren't really part of the plan. They're just sort of injected in there to help us understand it, and they're really cool. But they're like, you don't get actual things for like cost. Cost is always an estimate in SQL Server. Just always, always an estimate. Like, he agrees with me. It's good. So what we get in Query Store is kind of a combination of the two, or kind of a hybrid, because we get the estimated plan, and then we do get runtime stats, but the runtime stats are not for individual runs. In Query Store, you set an interval. So I think I have my interval set to an hour here. So what I get is I get the average logical reads over an hour. I get the max logical reads over an hour. I get physical reads over an hour, but I don't get it for every single run of the plan. So So it's good enough to be forced. Well, hopefully it's good enough to be forced, right? Hopefully you have enough information. I have had times where I've forced a plan and things got worse, right? Yeah. She does it all the time. It's really bad. Yeah, so, but the nice thing is you can monitor it in Query Store and say, are you getting better or are you getting worse? So there's something else we can do that's called automatic plan correction. Here's the description in the documentation for automatic plan correction. This is very confident documentation. Yes? Yeah.
Let's say you have a stored procedure that you're running, like calls from report server. Is there any way to force a plan that you found to be like the most like performance, like the best performance? You like force that at the beginning of the process, like find this plan and then run it?
Okay, so you've got a query that's running in a stored procedure, and in the stored procedure itself, you want it to check if it can force a plan.
Yeah, or like a stored procedure that like matches it. Like, can you force it like when it's being called from the report server versus like here we ran different plans and we're like, oh, this one's the best. We're just going to continue to force it by running it into our window.
Okay, so the question is around, do we have to force the plans from sort of analyzing them against the database and running it, or is there a more clever way, I think, that we could figure out if there's a better plan and optimizing it from an application tier, I think is what the question is. Okay, well, I think this next demo is gonna show some of why that's tricky. So that is a great, fantastic question, because this is Microsoft's attempt. So automatic plan correction is Microsoft's attempt to say, we know that your queries are sometimes fast and sometimes slow, and we're gonna try to be really clever, and when they get slower, automatically force a plan that we think is going to be faster, right? So what this feature tries to do is it tries to look around and say, if a query regresses, which means if it gets slower, right? I'm gonna look around and I'm gonna find a plan that was faster. I'm gonna force that plan, and I'm gonna see what happens. And if it doesn't get faster, if it gets slower, I'm gonna unforce the plan, and maybe I'll try to force another one. And another one. And another one. And if you have a lot of plans, it'll just keep going. So it'll force that plan. And if it works, like if it does get faster, it'll leave it for a while, but then things happen. Statistics update. Maybe your database fails over. These things are not persisted for very long. They're persisted in a table, but that table gets cleared. When you fail over, if statistics update, it just starts over. So what you end up with, it says in rare cases, it may not make it faster to just randomly force a query plan that it hopes is faster in rare cases. I have found these cases to not be so rare. So it's like you've got a little robot that's running around your SQL server, and it's like, hey, I'm gonna force this plan because maybe it'll get better. Oops, oh, it didn't get better. And then maybe it actually causes a real problem, CPU spikes, you get called in, you look around, and maybe it's not even forcing it anymore. And you're like, what happened here? Yeah, it wasn't Muppets. It was automatic plan correction. So let's take a look at one of my least favorite patterns in automatic plan correction. I'll try not to get too emotional. This actually does this does make me a little mad. I have feelings. All right, so we're resetting our demo. Here. Oh, why are we taking a while to reset our demo? There we go. I don't know. Why are we taking a while to reset our demo? All right. We completed. We were confused for a minute. So here is the setting for automatic plan correction. This is an enterprise edition feature, by the way. This is an expensive edition feature. And there is one thing I like about this feature, and only one thing. And the thing that I like about this feature, it isn't that it isn't available in standard edition. I mean, blissful. But the thing that I like about the feature is that even if you don't let it do the auto tuning, it will still show you the recommendations in sys.dmdb tuning recommendations, which is actually pretty good. Like, I am fine with it just telling me, hey, here's a query I think is sometimes slow, and then let me look at it and decide. Maybe I have control issues, it's possible, but I still think that's pretty cool. But we are going to turn this on. I've turned on force/good plan equals on, and now its desired state is on and its actual state is on. So here is the stored procedure that we're going to look at. And the important thing about this stored procedure is that it does something we often do in the world. We first select data into a temp table, and then we run another query and we select data from that temp table and we join to something else. Now, this is an incredibly common pattern in SQL Server because often if we have a very complex query, it can be slow. It can be too much work to ask the optimizer to do it once. So an incredibly common pattern that has been established and recommended frequently over the last 20 years by literally everyone is break your query into simpler parts. Use a temporary table to stage the core data for your query and then join back to it. This is used by so many people for query tuning. So the important thing about our procedure is that it uses this pattern. Part of why this is so effective is that temporary tables support column statistics as well as index statistics. And this means that if the amount of data we put into our temporary table changes, it can naturally cause a recompile for the second query in our procedure and get it an execution plan that's appropriate for the size of the data that we're dealing with. So first we're going to run this for, apparently in 2013, there were not a lot of Stack Overflow users named Clotilde. I don't know why, but we get a very small plan for this. We can see that the number of rows put into the temp table, here we go, let's scroll a little. There we go. Number of rows put into the temp table here, 0 rows, right? So very small plan. But if I run this for Kendra, there were a few Kendras in Stack Overflow 2013, right? Notice that our estimates are different here. 17 of 17. And if I run this for John, John Skeet, lots and lots of posts for John Skeet, sort of a famous Stack Overflow user, notice that this gets a parallel plan perfectly suited to the larger temp table. And this is because of using a temp table. This is what it's supposed to do. But what happens if automatic tuning kicks in? So I've turned off my actual execution plans. And here's part of the fun of automatic tuning is you have to run something a bunch of times before it'll start doing it. So if you want it, like when something first deploys to production, automatic tuning will leave it alone. It will lie in wait. Something has to run a bunch of times and it has to see something that it thinks is a regression. So I'm running this now just for all posts for any display name that starts with the letter J. And that will take a little minute to run. So while it's doing that, I'm just going to open my top resource consuming queries. I don't know why, I don't like the bar view. I always go to the table view because I'm a table person. And we can see post for display name is here, and this is actually our query with the join in it here. So if I refresh here, let's see, yep, a check mark has appeared. So let's look at the last 15 minutes, right? So what's happened here is our query started out, that table with the query with the temp table that joins to it. It started out with a little bitty plan for Clotilde. It then got more plans because the temp table naturally caused recompiles for it. But when it ran this plan for John Skeet that got the bigger size plan, which is a good plan, it's the plan I want. It's why I used a temp table in the first place. It said, oh, that's a regression. It got slower. Well, yeah, I mean, it is running for a much larger data set. It did get a little bit slower, but let's look at our average durations here. I'm going to switch this to average. We're looking at duration here. It is true that my average duration did go down, but does that necessarily mean that I don't want that plan? Let's take a look. For the plan that it's forced, and I'm going to pause. Let's do look at the tuning. So it put a row into the sys.dmv tuning recommendations DMV, and it explains what it's doing, right? It says the average CPU time changed, and I am verifying it, and it is revertible. I'm doing it. But now if I run this for all names that start with J, and I run this for this query, it is doing that nested loop plan. And that nested loop plan can take quite a while. So the nested loop plan takes 5.5 seconds total, of which a lot of the time is this key lookup that it's forcing here, right? Every single time it runs. If I unforce the plan, which I'm going to do just sort of lazy-like over here, so I'm going to go ahead and click on the forced plan here and unforce it. Now if I run this again, and the temp table allows it to recompile, it finished in 2 seconds this time. So this is a very, very simple example. I have found really, really dramatic ones in production environments where I think this is a product management failure on the feature personally, because people have been using temp tables to do performance tuning for years. I think this thing should just ignore queries that have temporary tables in them. Right? It will ignore things that have recompiles in them. But I think if you're using a temporary table and you're joining to it, you may be counting on that to recompile, and going in and just forcing that plan is just basically undoing everything we use temp tables for. So there's other issues I've had with the feature. It really, some people do like it. I am saying this is very much my opinion, but to me, I do not recommend using this feature. It can make things faster sometimes, but it also will make things slower a lot of times. And it just really, it's like working with a SQL server that is vaguely haunted, because you'll have these experiences where you're like, why were things slow? And you have to basically try to dig into that table and hope information is still in there in order for you to be able to kind of guess what it was doing at the time. Oh, I think there was something I actually wanted to show you more in that demo. Let's see if it's there. See if it actually happened this time. If I go into this query now, oh, I already unforced it. Let's see if I have a fragment of it here. I do. So on that demo, it actually was doing something with a morally equivalent plan there. So I still have a plan that has use plan equals true in the properties. But if you're like wondering about why something's running even though you forced a plan, here's how to see that use plan equals true. You click on the leftmost operator and you look in the properties, and this is the thing where if you've had a morally equivalent plan happening, it'll say that's the little weird note left behind about it. All right. This stored procedure for SP configure automatic tuning was documented in 2024. Eric Darling and I both wrote blog posts about how we wanted the ability to tell automatic tuning to leave things alone. She complains a lot on her blog, and Eric had found this stored procedure. Like, it was undocumented, but he'd found it in the mists of SQL Server metadata. And he was like, why don't you document this? And finally, it actually got documented. You can tell it, basically you give it, oh, I've got the wrong thing on this screen. This slide is wrong. It's not SP configure automatic tuning. There's a different procedure that you can use that, let me actually, we're gonna go a little off the rails here, and we're just gonna do, let's see, Eric Darling, automatic plan correction. All right, so I did a blog post on this as well. Here we go. Somewhere in here. Oh no, this is it. It is right. See, this just confuses me. So type value is a query ID. This is what confused me. Type value, you put in the query ID, you don't want it to automatically tune for. So I guess the idea is this will eventually be able to do things more than automatic tuning or more than automatic plan correction. So you tell it the type is query and then the type value equals 1. And then you tell it off. So you have to remember that type value is the query ID. So the mistake that I made is I didn't make my slide clear enough for myself to understand. Now, the reason that I am not a huge fan of this is, let's say you have many databases. Does anyone here have a database in production where you run multiple copies of the same schema in different databases? Yeah. So here's the problem. Your queries in every single database you have, they have different query IDs. So if you want to say, ignore this query, you need to figure out in every single database, what's the query ID for this? It's a hoot. And I actually find if you have to do this, the query hash, one would think that the query hash would be the easiest way to find the same query on different instances. I think the query hash includes the database name in the query hash. So the SQL handle I've found is the if you need to find the same query in multiples, that's actually the best option. But yeah, I'm not a huge fan of it. And I do, sometimes I use recompiles on things just to make automatic plan correction leave something alone if automatic plan correction is on. So why would you have automatic plan correction on anywhere if you don't like it, Kendra? So here's the thing. Here's the reason I am telling you not to turn this on is once it's on, it's like ants in your pantry. It's hard to get rid of because there are some things it will make better. It really will. It will make some things better. It will make some things worse. But it'll make some things better. And so in order to turn this thing off, you have to find all the things it's making better, and you have to fix them by other means so that when you turn it off, you don't have a bunch of regressions happen. So ants in your pantry, you can get rid of ants in your pantry. It is possible, but often it doesn't mean just cleaning the house. You've got to like really dig in and get rid of this thing. So that's, yeah. There's another thing too. So if you use automatic plan correction, or if you have ever used automatic plan correction, maybe your coworker turned it on, maybe it wasn't you. It may have gone in there and forced a lot of plans, and they may have ended up in a weird state called general failure. So here's how this goes down. Automatic plan correction forces a query execution plan. Then the query starts running again, but something happens and the query is canceled before it finishes compiling. And some queries can compile for quite a long time, by the way. So like queries that can compile longer and longer. If you use anything like Entity Framework, you probably have queries that can take a long time to compile because it writes very complex queries. But if a plan is forced, and this is whether it was forced by automatic plan correction or you, if a plan is forced by anything, and then it is canceled while it is still compiling, it will go into a mode called general failure. And I don't have enough time to do a demo of this today, but I do have a blog post that has the demo on it that walks through it. And basically what will happen is when a query plan is in that forced failure state in Query Store, the future compilation for that query will go up dramatically, or it can. I don't think this happens for every query, but it happens for a lot of queries. So in this example, there's a query that took, I think it takes 45 seconds total to compile. You can tell it's compiling when it's in this SQL source transform state, and I do give you the query for that. After it gets into the forced failure state, and this is a massively gnarly query that doesn't compile that well, you can see that in that general failure state, I just canceled it after this point. It had been compiling for 60 minutes, and I was like, I'm not waiting any longer here. So I filed a bug about this with Microsoft support. I do hear that this might be fixed someday, but I very much recommend running an automated script, and I also have this linking to, I have a sample of an automated script that will roll through all the databases on an instance. This is assuming you have a SQL agent and you're not running Azure SQL database, but it'll run through all of your databases. It'll look for any query plan that is in a forced failure state, and it will just unforce it. It'll just unforce them all. So if you have automatic plan correction on, I recommend you run this all the time. Just constantly enforce them, because you might have situations where things are just actually timing out because once it was canceled when it was still compiling. So I think there's more than one bug here, because I don't understand why we would want something to go into a general failure state just if it was canceled once when compiling. Like, why put it into the penitentiary forever when it just said, oh, I don't want to run that query this time. But also that long extended compilation time, definitely not the best bug. So that is an issue with plan forcing, whether by automatic plan correction or manually. You're just much more likely to run into it if you use automatic plan correction. All right, so query store hints. Query store hints are delightful. So if you have a query that is captured in Query Store, you can create a hint and say apply to this query, and then when the query executes, Query Store will add that hint on. So it's great. It really is just like, hey, psst, I've got a hint for you, query. So let's take a look at Query Store hints. And if you've got more questions, I can field more questions too. Happy to do that. All right, I think we're good. All right, let's reconfigure our database here. We are creating an index on comment count this time. So the posts table has a column called comment count, and we're creating a procedure that is looking for posts where the comment count is greater than or equal to the comment count that is passed in as a parameter to the stored procedure. So very similar pattern to kind of what we've been talking about. There are not a lot of posts that have high comment counts, right? So we've been talking about like sort of bad parameter sniffing issues are what most of my examples are here. So we've got a comment count of 100, and there's 6 of these, and here's the time range they're from. Let's look at the plan for that. I did Control M there, which did not work. Maybe I'm not hitting the control button. We'll do our actual execution plan button. There we go. So here's our little key lookup plan for those who have very high comment counts, which is a rarefied bunch. But lots and lots of posts have 3 comment counts or more. So this starts to be slower when we run this for 3 comment counts. And we can kind of see, yeah, this was optimized for 7, but we actually did it 3.7 million times. So not the fastest. So let's say, in reality, if I had an issue with this in production, there's really 2 ways I would look at this. One, I would look at, can I get rid of this key lookup? Right? This key lookup is only really outputting the creation date. So I'd see if I could just pop that on the non-clustered index, or I might put a recompile hint on it. But I wanted to show you a question that I looked into that I thought was interesting. So let's say to fix this problem, someone did put a recompile hint on the stored procedure itself. So now our stored procedure says don't cache the plan for reuse after you run. Generate a new plan every single time. So the comment count 100 still gets the same plan, but now that we've got that recompile hint in there, our comment count 3, it gets its own plan, and it's like, that's so many posts that I'm just going to scan the clustered index, and I will use parallelism for this. So if let's say I come along later and I'm like, I don't know about that recompile hint. Maybe this thing runs so often. I want to see if can I do something other than that recompile hint. I can see how many times this thing has been compiled, right? This thing has been, if I look at this in Query Store, actually, let's look at the plans and for query ID 6. So let's first, before I get too excited, I'll open my tracked queries and I'll look for query ID 6. And let's look back for the last 15 minutes. And these are very similarly colored. I don't think there was a designer when Query Store was involved, but they are actually 2 different plans that we have there in Query Store. So I'm going to see if I can put a hint on these. We do have, of course, this option recompile in the text of the query. So let's say I want to optimize this for something else. Now, one thing we cannot do, and this is kind of a bummer, but I'm sure there are very good reasons for it, is we cannot use an optimize for comment count equals value hint. This is just not supported by Query Store hints for optimize for value. It is documented. This is not like breaking news or anything. This just isn't one of the hints we can allow. But we can add a hint like optimize for unknown, or like I like to call it, optimize for mediocre. Look for like the most average, just like if you didn't have any idea what the parameter value was and you just sort of had to guess based on like the density of the table or kind of the cardinality of the table, if you just sort of had to make a random guess, what would you do? That's what we're saying with optimize for unknown. So here's the thing I was looking into that I wanted to make sure of. If the query has in it option recompile, and I add a Query Store hint optimize for unknown, have I effectively erased the recompile hint? So we can tell, right? So we can tell. So if I look at my query in Query Store, I can see right now it has been compiled 2 times so far. Now, I do expect the first time I run this, I just added a hint, so it is going to need to compile the next time it runs. So I expect this to go to 3. So I run it once, and it turns out optimize for mediocre gets me a clustered index scan, right? So if it didn't really know what the value was, it would be like, I'll just scan the index. I don't know if that's necessarily the best choice, but it's what we got. And now we have 3 compiles, which we expected. But if I run it 3 more times, hopefully it shouldn't compile for these. Now, it is going to run optimize for unknown on every single one of these. Now, it doesn't erase the hint from the query text. That query text still says that, but if I look at the properties of the query in the query window, I can see that there is a Query Store statement hint on here that is option optimize for unknown. So you have to know to look in the properties if you start using these things. The truth is hopefully in the properties if it's out there at all. So that's how that is in the properties. And did it recompile? Automatic plan correction, you be gone. There we go. So did it recompile? Nope. We are still at compile count 3. And this is in the documentation. I just wanted to make sure it was true. When you hint anything in query store, it will replace any hints on the query. So it might be that there's a recompile hint there and you want to keep the recompile hint, but maybe you want to say, you maybe want to add a hint to say use the legacy cardinality estimator. In that case, you would want to add a hint that includes both recompile and the use hint for use the legacy cardinality estimator. So make sure that you're not accidentally erasing one hint if you want to add to it, because it will just replace hints on there. Yes? So will the same thing happen if you create the stored procedure with recompile here? So I believe that you would put that like here, right? With recompile. I think that's where you put this hint. I recommend that you never ever do this. So this, this is a way to say recompile. But the problem with this, if you put recompile in the header, effectively you are making your query sort of invisible from the query execution plan cache. If you have an external monitoring system, a Datadog or a Redgate SQL monitor or a SolarWinds or whatever, looking at this and it tries to monitor using the plan cache, it will not see your query at all because of this is like a cloak of invisibility on the stored procedure. It will still show up in Query Store, but most monitoring tools don't look in Query Store. And you won't be able to override it with the query hint. Now, I am going to double check that, but because I don't know that I've ever explicitly tested it, but basically Query Store is all at the query level, not at the stored procedure level. So I don't think it would know how to override a hint at the stored procedure level at all. So I will do a blog post to check on that and like 100% sure, but I'm like 99.99% sure you couldn't undo this type of recompile hint with a Query Store hint, just because it's query level. Okay, so yeah, I wish this would be deprecated, the with recompile in the header of the stored procedures, because it just makes things so invisible. Yes? Yes, with the query store hints, and I think this is also true with plan freezing. Is there any risk of like, what happens if you lose data in query store? So what happens, I mean, also your query store could become read-only. If your query store fills up and becomes read-only, things stop working with that plan forcing. But also, if query store gets cleared, now, if nothing gets weird and data is just aging out, I don't think it will remove forced plans from it, like if it's been idle for a very long time. But like if query store did get cleared by some reason, yeah, then everything starts over again and that's no longer valid. So I think that's part of the reason why to always treat these as like a temporary fix. Don't count on these working forever because things happen. Query stores sometimes get cleared or they fill up and become read-only. Okay, what if we wanted to just clear the hint and not replace it with something else? What if we just wanted to remove a hint? Well, weirdly enough, so I'm going to go ahead and clear the query store hints. Weirdly enough, it will let us do this, and it's successful. It will let me add a hint with no value on it, but if I then look at the hints, there's nothing there. So I just ran this query that says, show me all of the hints in my query store. So I can run this, nothing happens, right? And I think, let me make sure. Yeah, query ID 6 is still correct, so nothing there. If you want to just remove a hint and not add anything else, I should dedicate this session to Eric because this was his idea too. Just add a meaningless hint. Here's a really super meaningless hint. Option minimum memory grant % is 0. That is what it is no matter what. But if we add this meaningless hint, that will effectively replace the recompile hint in there, and I can prove it. So we're currently at 3 compiles, right? We just added a hint, so we should get one more. So here we go, we should get one more. But if I run these two, they should not add to our compile count. So yep, we're just at 4 compiles now. So if you just want to get rid of a hint of, oops, that hint wasn't good that we actually hard-coded in the query, just add something that tells it to do what it was going to do anyway. That'll get it. You could also add like with no expand views, and maybe it doesn't even reference an index view, like it's just irrelevant, an irrelevant hint. So that's, you can add hints and you can erase hints. So here are the supported query hints that you can add with query hints. And here are the things that you cannot do with query hints. And I don't think any of these are too big a deal. The table hints, maybe I'd like them. I'd like to be able to remove a no lock, maybe. I don't know. So interoperability, there's some limitations on this. Effectively, I don't run into these too often, but here's the thing that actually addresses your question. Manually created query store hints are exempt from cleanup. So it will try not to clean up the data if you do put a hint on something. But like I said, things happen just in terms of clearing query store. Yeah. Are hints only Enterprise Edition? Let me go back a few slides because I have a terrible memory. All editions, I looked it up. I knew that there would be questions, so I Past Kendra did me a favor and checked it out. Past Kendra is the best. All right, our final P. Oh, yes. If you run a query with a hint in it, and there is a query store hint that is overriding it, will it tell you? The only place it will tell you is if you get an execution plan for it and look in the properties of the execution plan. Yeah, so that is the way it tells you. It will tell you very quietly. Yes? What will be the difference if you have a plan guide and you have query store? What if you have a plan guide and you have query store and you do both? So I believe that it depends on the type of the plan guide. So if you have a plan guide for like the forced parameterization, you can still force a plan, and I think you can do a query store hint. I actually don't know about the other types of plan guides, so I would have to check. I'm not sure. I think it is documented. I just can't remember. Yes?
If you happen to have like automatic plan correction enabled, and then you had I don't know, I'm going to say plan number 1 that was working fine, and then you got another plan that is just performing that, any chances that maybe you happen to disable automatic plan correction setting?
Yeah.
Or it goes back to the original that was performing, and now you're stuck with the plan that is
Great question. So if it's to rephrase, if you disable automatic plan correction, will it unforce all the plans that it has forced? I believe not. It does not have a great memory. And this could be good and this could be bad. Like if you are happy with the things automatic plan correction is forced and you want to leave them for a little while, you do have that option when you're turning it off. And in fact, I remember now, like it will not unforce all the plans when it turns off. So yeah, you have to go through and unforce them if you want to after you turn automatic plan correction off. Yeah, in fact, I think I've had times where I've found plans that are forced and automatic plan correction says it's not working on it. And I'm like, well, and it says force type equals auto. And I'm like, well, then who's doing it? So it might be that I am haunted though, but I swear I've seen that. All right, our final P, parameter-sensitive plan optimization. Okay, Dave will come back at the end. We'll come back at the end. We're a little short on time. He's having a nap. SQL Server is increasingly sensitive. So parameter-sensitive plan optimization is for a lot of these cases like we've talked about with parameter sniffing. And it isn't that it makes parameter sniffing go away. It's sort of like a stronger nose. So it's sort of like a super smeller SQL Server for equality predicates. Are any of you super smellers in the audience? Are any of you? Oh, okay, we have a few super smellers, and I am related to a super smeller, and I have to say, I admire you for making your way through life. That is not hard, or not easy. That is hard. And I think parameter-sensitive plan optimization is kind of hard in a way too. So I think the easiest way to show this is in a demo. Let's take a look at parameter-sensitive plan optimization. We're going to use the exact same query from our last demo, but with one change. All right. We have our index, which I think I just recreated just like before. So the only difference is that before I had comment count was greater than or equal to, now comment count is equal to. So parameter-sensitive plan optimization, as we know it now in its glorious V1, only works on equality predicates. And it will only do one equality predicate per table. If you have like multiple tables, or if you have a union, and you might get more than one just for like each query in the union. It can do more than one equality predicate, can do up to 3 for a single query, but they have to be like for different tables. So ours is very simple. We're just doing one table here. So we've got our comment count proc. And as soon as I run this query, I'm going to include my actual plans. Things look normal at the beginning. So I ran it for comment count 1, where it decides to do the clustered index scan. But if I go into the properties, and I think that the theme of SQL Server 2022 should actually be, welcome to the properties of your query plan. You'll be spending a lot of time here because everything we need to know is now in the properties. We can see that there is a dispatcher node, and we have, not next to it, that would be too easy because we have to alphabetize, we have a query variant ID. So I am query variant ID 3. And if I expand my dispatcher, I can see that there is a high boundary and a low boundary, and it tells me what predicate that's for. So I have values that are below 100, values that are between 100 and, if only we could afford commas, 1 million, right? Someday they're going to save up their money. And then maybe that's what that OpenAI stuff will get us. Maybe it'll get us commas. That would be exciting. And then we have values that are over 1 million. So we have three different zones there. So let's run a few more queries. So comment count 200, right? I got to go back to my properties. All the good stuff's in the properties. And sometimes we just get our connection properties. There we go. Now we're here. All right, we have the same, dispatcher values. Now we're query variant ID 1, right? And now I ran this for 200, so this one should be in the middle, right? 1 was comment count equals 1 was variant ID 3. Now I'm at variant ID 1. Shouldn't 200, wait, let's look at these boundaries again. If 1 is below 100, and that got query variant ID 3, shouldn't this be 2? I mean, shouldn't it? You'd think, yeah, you'd think, I don't know. So let's look at above 1 million, 1,000,001. If I go above 1,000,001 and I look at my values here, I still have the same ranges, and I'm still on query variant ID 1. So I don't know. For this one, it's really only using query variant ID 3 and query variant ID 1. I do have 2 boundary points, but they're kind of meaningless in this case, I guess. I don't know. It's kind of weird, but I do have the dispatcher plan. So one very important thing you need to know, if you're at compat level 160, you'll have this on unless you've disabled it in like the database scoped configuration. So one very important thing to know is if you have these, let's say we wanted to do that same thing and we're like, here's my normal workflow. I look for the query ID, and it's query ID 5 for my query and comment count, and then I grab it, and then I go into tracked queries, and I look for query ID 5, and I'm like, okay, where are you? And there's no bubbles. There's no bubbles. Now, I think this is kind of a bug. This is showing this from before. If I actually reopen this, I reopen tracked queries, and it's not displaying anything, and I enter query ID 5, like, it doesn't pull anything up there. So query ID 5, the query I've gotten from the store, like show me all the queries in the stored procedure, this is actually the dispatcher plan. The dispatcher plan hasn't actually run. Only the variants actually run. So the dispatcher plan sits above the variants, and it hasn't actually executed. So it is not going to show up in tracked query view because it hasn't executed. It's a little bit like how dynamic SQL shows up in query store. What I actually have to do now is I can grab this query hash. So I do know the query hash from my dispatcher, and that's going to be the same for the variants. They'll all share the same query hash. So I can say, okay, show me everybody in query store for that query hash, and now I can see, okay, here's my dispatcher plan. It's the one with the object ID, but on the variants, they have object ID 0. They're sort of just out there. They do deep in the XML have the object ID in there, but query store doesn't know about it. So I can look them up this way. I can say, okay, I want to see query ID 6. Right? I want to see how it ran, and here's the plan that it got, and I can see query ID 7 as well and the different plan that it got. And in Query Store, I can also see in the properties, I can see the same dispatcher info, and I can see the variant info. So it's a little bit weird, it's a little bit strange, but basically we can have, I mean, this I think is very interesting. I'm not necessarily super sold on this, and here's why I'm not super sold on this. How do I know what's going on at any given time, right? So this is a matrix showing like what happens if there's a hint applied to the parent or the variant and you're using all these other features. And I have not memorized this diagram. I do not wish to memorize this diagram. I have enough problems in life, all right? So I don't hate this feature, but I do have to say, with all of these features, there's more features in 2022, like memory grant feedback, cardinality estimation feedback, DOP feedback. There's all sorts of things now that want to put hints on your queries. An automatic plan correction forcing stuff on your queries. When something goes wrong, figuring out, okay, what happened? Really, really hard. If it isn't happening anymore, it's ridiculously hard. So I do have a few lessons learned. Before I finish, there's one thing I want to say. So Query Store has weight stats collection. I love weight stats in SQL Server. They're fantastic. I do not collect weight stats in Query Store. And the reason I do not collect weight stats in Query Store is that cleanup of weight stats in Query Store will make you incredibly sad if you have a synchronous replica, because it just pokes your query or your Query Store over and over again with tiny little cleanup queries. And it tries to clean them up. And your availability group gets very, very sad. I reported this issue to Microsoft, and they told me I was using recompile too much. So I don't know, maybe it'll get fixed someday, but something went wrong in that support ticket. So hopefully someone reads my blog post, I don't know. So my reviews of all these features. I don't use plan guides anymore. They're just too complicated to use. I fully have replaced it with Query Store hints. Plan forcing and hints, I use all the time. Love those features. I love Query Store. I do try to avoid size-based cleanup, which can also make it slow. Unfortunately, size-based cleanup is based on the time your SQL Server restarted, and it's not something you can, size-based cleanup is based on size. That can be really, really slow. Also, time-based cleanup you have to be careful of. Time-based cleanup is based on the time your server restarted, which hopefully we get a parameter for someday. I haven't yet warmed up to parameter-sensitive plan optimization, but I'm curious. I'm open. I'm not saying never. I am saying life is complicated. Automatic plan correction, I wish I didn't know its name. So to using these tools successfully, try not to use everything all at once at the beginning. Try to keep it simple. Document and troubleshoot runbook. Make sure your puppet can understand your runbook and what to do when things go wrong, and treat these all as temporary fixes. So thank you so much for coming to this session and to pass. I've kept you 2 minutes over, but thank you. I really, really appreciate it. Please evaluate.